Hi, good morning, everyone. My name is Dr. Jim Gorny. I'm the Executive Director of the Postharvest Technology Research and Information Center at UC Davis, and welcome to our webinar this morning on maintaining the quality and safety in California fresh strawberries. And first and foremost, I'd like to thank the California Strawberry Commission for their support and collaboration on this project. Our agenda is we have a series of speakers, which you can see on the screen here. Myself will be doing the introductions and moderating. Dr. Trevor Suslow from UC Davis in the Plant Sciences Department will be talking about the role of product testing to assure product safety. Jim Thompson, an extension specialist at UC Davis and Ag Engineering, Bio and Ag Engineering Department, will be discussing transportation and distribution center handling of strawberries. Beth Mitchum, an extension specialist in the Department of Plant Sciences, will be discussing retail and food service handling. And Chris Christian will be talking about current industry best practices, and we'll have a wrap-up with an additional Q&A. What we've hopefully scheduled here is a very interactive session with about 10 minutes of PowerPoint presentation by each presenter, followed by about 10 minutes of Q&A. And with that, I'd like to get started. Dr. Suslow is a cooperative extension specialist here at UC Davis in the Plant Sciences Department, and he's going to talk about the role of product testing to assure food safety. So at this point, I'll hand it over to Trevor.
Okay, and can you hear me all right?
Yes.
Okay, great. Well, good morning. I'm very happy to participate, and what I've outlined for a brief presentation are really some of the background that I think is essential to really have a dialogue between the suppliers and buyers around issues of food safety and product testing. I've been asked to focus predominantly on pathogen testing, and so why don't we go ahead and get started. It's certainly this whole area of microbial testing, which has many components, is heavily practiced, but when we encounter questions that come up or interpretations of the information, it's clearly one of the less understood parts of food microbiology and quality assurance. And as I've said, I'm going to focus really on pathogen testing as that has become more commonplace across different commodities, and a number of issues arise as you contemplate entering into it as to does pathogen testing make sense for the product or environmental testing? Exactly how do these test and hold or positive release programs function? What are some of the options for managing them so you can effectively use the data? What exactly does a negative result mean? And sort of within that, obviously, what are the actions one might take if you do have a positive result? I'll also briefly cover really where we feel science suggests that pathogen testing would most appropriately be used as a tool for improving best management practices or GAPs, good handling practices, however you want to define it, and then just walk through some samples and issues as it relates to sampling and testing design. So if you're going to enter into any type of pathogen testing or microbial testing for pre-harvest or pack product, you really need to understand the goals and the assumptions that surround the specific test procedures, sampling design, and all the other characteristics of the testing program so that there can be a meaningful dialogue surrounding the data and what actions that data might suggest need to be taken. So if you kind of ask the question, does pathogen testing make sense as it relates to providing levels of assurance of food safety, and some of the different reasons are listed on the left-hand side. And what I tried to do from my perspective is sort of match these reasons for testing to fresh market strawberries from California in particular. So is it a regulatory recommendation to do pathogen testing? As far as I'm aware, the answer is no. Is it a requirement? Again, no. Are strawberries part of a pilot test program under a regulatory authority for a diversity of pathogens? No. The issue, of course, is it being requested as a buyer requirement or a supplier preferential supplier agreement? That, I think, is sort of up for question. I won't touch that. You might decide to do targeted pathogen testing based on product history as it relates to outbreaks and illness, and some have suggested that perhaps you might screen for human viruses or a few other things. Again, it's been pointed out that the association of those pathogens with strawberries really was for imported processed strawberries. It's not really part of the food safety history or experience with fresh market strawberries in California. And it's really not sort of a blanket in-house marketing or hazard analysis critical control point program as it relates to strawberries, whether pre-harvest or post-harvest. So the match criteria don't seem to really point towards a strong, compelling argument for pathogen testing. So what are some of the reasons that you wouldn't want to test? I think one of the main reasons that we've always argued from a science side is that there's really no scientific validity in the case of these particular types of products. There's a very poor correlation to the other types of testing that goes on, which I won't be talking about today, but could certainly answer questions using of different indicators such as fecal coliforms or total coliform or E. coli. And because of the distribution, or really the absence of pathogens in the broadest sense, you're very unlikely to detect pathogens at any reasonable or practical level of sampling and analysis. From that standpoint, again, scientifically, the cost would appear to be, too high relative to the actual value in assuring food safety. Again, business reasons may override the science, but that's the part that I'm sharing with you here. And the other, of course, is that which pathogens do you screen for? There may not be really practical or functional tests available for highly perishable commodity like strawberries. So to screen for viruses or parasites or something else, the length of time it would take if you're trying to qualify product, simply put it outside the realm of practicality. And of course, another reason that many don't want to test is that they simply don't want to know, and that may not be the best reason. So some of the testing considerations for pathogens, as you establish an interaction as to, whether it seems worth the cost and effort, are the specifications that are being requested really achievable? Is the test method, sampling regime, and specificity going to provide the information that you're really after? And all of these things need to be worked out up front. Is the action policy for a potential positive established, and how will you follow it? Defining the types of formal changes or deviations from any type of pathogen testing program in writing, and those, again, need to be all worked out before you ever take the first sample and before you ever have a result. You don't want to be figuring these things out in the middle of trying to deal with the data in front of you. So one of the most important questions that has been discussed really, for the last year and a half, much more so than the past, is that can raw material or packed product testing be an effective firewall to really achieve what we all want, which is to protect the consumer as well as protect the business. And, this is where you have these test and hold or test and positive release programs. They basically function on a pass or no pass response from rapid test kits. 8 to 12 hours for typical turnaround time for most pathogens is achievable. For some things, depending on what you do, Salmonella might take up to 24. But the overriding goal is to really prevent the introduction of the pathogens into a facility, and here I'm talking predominantly about a processing facility as opposed to a shipping point. And again, the characteristics of strawberry handling tend to put them, into a category where, cross-contamination or commingling really wouldn't happen, particularly in the absence of a wash line process. So you have the product then under a positive lot release, due to a response, which I'll come to in a minute. And the overriding objective is to really prevent any of that product reaching the consumer and to try and help improve consumer confidence in the overall category of fresh produce. The problem comes back to what I discussed earlier, that in terms of probabilities of effectively finding the very low numbers that may be out there, it's a very unlikely event relative to the effort that is reasonable for the product that we're talking about. So what are some of the requirements for an ideal pathogen test? The ones that are most used fall into three types of categories, predominantly two: the immunodiagnostic or the pregnancy test type of format, the DNA-based rapid PCR or real-time PCR you may have heard of, and there's a lot of interest and effort in developing biochips or biosensors to do sort of broad-scale multi-pathogen testing in a very real-time methodology. This slide is really more provided for background that, again, you can read when you have an opportunity. The key point here is that all of the certified or performance-tested methods that are out there have to go through a series of tests to really ensure that they have the selectivity and sensitivity to meet the requirements that are designed for the specific commodity type. And the ones that are used, what we know is that they're quite often developed more intensively for other types of food products, and they have yet to be fully evaluated, particularly for the selectivity component, which means that you can really focus in on the pathogen of interest and get a positive reaction in the presence of high populations of closely related non-target microbes that are non-pathogenic. And so as we apply them, to each of the different commodity types, we learn more about the potential for interference from the environment and this problem of having false positives. So very quickly, the ones that we have been testing and the ones that are most commonly used in commercial labs are, again, these lateral flow devices or the pregnancy type tests. Two different formats. There's another one which is a little bit simpler, but has a little bit more difficulty with some of the background interference. Two different types of DNA testing. One you may have heard of, the Pathogen or matrix methodology, which really has been used more to rely on actual culture confirmation or colony confirmation of the pathogen. So it tends to take quite a bit more time, 2 to 3 days to confirm. You can use it in the same sort of 8-hour, 12-hour time frame. And the others, which are designed really to take a lot of the decision-making or subjectivity away from the operator, in a handy, convenient kit format, and you have this sort of stoplight approach to, red or positive means, of course, don't ship. It has internal controls to identify when there's problems with the identification of the specific reaction that's going on. So there you may get a question mark or there's been a problem. Thank you. And of course, the green, no detection, go ahead and ship. No pathogens are detected at that level. We've been testing a couple of different formats that are among the more common ones in contract labs as well as in internal companies. This is just an overview of the kind of screen you get. This is with some leafy greens, not strawberries, but you can see you get a range of reactions depending on what's going on with the background microorganisms, the other types of materials that the plants may produce themselves that can often interfere with the reaction that are all can be overcome, but you just have to learn these things and learn how to deal with them. And then finally, one that you may have read about or heard about a lot is a company, IEH, which has a proprietary system not available as a commercial kit for sale like the others I've been talking about. It has fairly recently achieved the certified performance qualification through AOAC, but the way they manage it, it really takes an individual, a skilled individual, to interpret the genetic banding pattern, and again, it falls into that same sort of category. An 8-hour initial reaction can be determined, and then, if needed, a 4-hour confirmation. And you can look at a couple of different primary pathogens, E. coli, Salmonella, all at the same time. So you can't set this up for yourself, but they do this as a service for a lot of labs, and they have on-site testing. So one of the key issues is that confidence in pathogen detection using any of these systems is really come down to much more of a sampling issue than a test system sensitivity. A lot of improvements have been made in both sensitivity and specificity, and there's really limited statistical validity to looking for pathogens in a field, such as the strawberry field, as compared, say, to residue testing, where you may be applying a particular agrochemical in a very uniform manner, and assuming that there's sort of a controlled decline, it's reasonable to go out and pick a certain number of samples and expect to be able to find fairly good uniformity in testing, even at very low levels. That's not true for pathogens. They are always very much non-uniform in their distribution of contamination when that's been successfully studied. More often than not, even in very extensive surveys, the prevalence is less than 0.1% of the total samples that are taken, quite often much less than that. Although in certain areas, some of the handled leafy greens, there have been in FDA surveys as high as 16%, but none of that is certainly true for fresh market strawberries. So that really means that statistically valid sampling plan is very difficult to define to really assure food safety, and the likelihood of a false negative, which simply means it may be there at extremely low levels, but you won't catch it with a typical testing plan, really increases. So if you look at this particular example, it gave kind of a generous level of contamination, about 2%. Even if you took 30 composite samples, you have only about a 50-50 chance of finding pathogens that are actually there. So, of course, if you're down more around the 0.1%, it would be highly unlikely that sampling would uncover the presence of pathogens should they be in the field. So one of the things that about strawberries that would suggest really makes their risk profile extremely low, and therefore any sampling plan highly unlikely to give you much value in terms of finding something. And many of the things that have been mentioned earlier, because the soils are fumigated, the plants are, the beds are covered with a plastic mulch, it's on drip irrigation, there's a lot of emphasis on worker training and periodic reinforcement of personal hygiene and sanitation, and the fact that the berries are forced air cooled. They really don't come in contact with water. They don't have a step where you might expect to have an increase or redistribution. All of these things don't say that it can't happen, but it just makes it, again, very unlikely that you could pick it up and that pathogen testing would help you. I'm only going to really mention one aspect. One of the bullet points here is that certainly pathogen testing, can be very useful for baseline setting as a research tool or periodic verification of your, best practices. It certainly can be used in response to observed concerns, more of a targeted sampling and assessment, but, perhaps not as a routine practice. So very quickly, how would you design a test and positive release program? You can sample a lot of samples and handle each one independently. Next, it is certainly statistically valid to composite them and run them. What is not a reasonable approach is to take a lot of samples and then take a subsample from that and process one. That is less expensive, but it really will be even less likely to help you. And it is statistically valid and both practical to do what's called a wet compost. So again, these all go to how would you design a program, whether you're the producer, the supplier, or the buyer, what would you ask for? This is a very reasonable approach. So coming back then to this question of where does product testing fit in as an effective firewall? Some of the problems with sort of forced testing programs, ones that are designed simply to be there rather than to really define food safety assurance. I think the biggest issues is that lot definition becomes very artificial, and the reaction to positives, hasn't been well worked out yet. So I think this is the last one. If pathogen testing is going to be done, you really need to define the critical detection limits and work out, the corrective actions in advance and understand, exactly what you're going to do with each outcome before you ever enter, and, really fully discuss and agree on what it does get you for food safety assurance. So the question that really needs to be answered across the board is the cost of pathogen testing really justified in terms of measurable contributions to public safety? And if there's an opportunity or time for questions, I'd be happy to try and take it.
Great job, Trevor. You covered a lot of ground in a very short period of time. Thank you for doing that. Do you have any quick questions for Trevor?
Just as we have false negative, I'm sure that we find presumptive positive as well. Would you recommend that if we do find a positive, that we should retest the sample by a different method?
I think, how positives are handled, as I was trying to suggest, really needs to be well worked out, in advance. And, there are a number of approaches that can be taken based on our own evaluations of the different rapid test methods with leafy greens. I think one of the things that should happen is you can go directly back to that primary enrichment culture, as it's called, and look at that then with a couple of other test methods that increase the specificity and look for other characteristics of the pathogens that would have to be there if it was a true positive. I think that, to me, is the most sensible and quickest step to take, because whatever triggered the response should still be there. Many people do go back and retest, and that's fine. I think that's a good compliment, but I don't think it's appropriate or meaningful to ignore the primary sample that was taken. And they can all be designed and managed to do that very effectively.
So in order then to be positive, that we did find a positive, your recommendation is to retest the primary sample and possibly pull another sample and retest for that. But the likelihood to find another positive is probably slim to none, as can be seen statistically.
Right, but again, that is why, choosing the, a retest outcome over the primary outcome, to me, just isn't supportable scientifically. I mean, there was a reason that you got a positive, and, quite often it does turn out to be a false reaction due to some interfering other bacteria that carry, similar traits, but all of the systems are available to work through and confirm whether or not you can pull out what triggered the reaction.
Okay, thank you.
Trevor, but anyway, I'm glad that you had alluded to the practices in the spinach as compared to the strawberry, because that's what triggers a lot of people asking for pathogen testing. Do you agree that the effective way to prevent contamination, microbial contamination, in strawberry farms is to implement, enforce, and verify effective stringent food safety programs such as good agricultural practice programs, farm risk assessment, operational risk management, and GMPs where it belongs?
Yeah, I mean, you basically said it yourself there, Tony. The thing is, in terms of approaching, whether or not it's a wise use of resources to do product pathogen testing on product, particularly one like strawberries, is that if you have a verifiable, comprehensive food safety program in place, it makes it even less likely that a sampling program that you could implement would ever detect anything should there happen to be, very, very small, infrequent numbers present. So that is really what you base the protection and reduction of risk of pathogen introduction is through the food safety programs. And then certainly pathogen testing or other types of microbial testing, can be used as effective tools to verify that these things are true, and particularly in specific situations. They can be very useful information gathering, but my sense is that it's not, for the value that you get in food safety assurance, it's really not something that would be entered into lightly as a matter of routine.
Thanks, Trevor, and we're going to kind of switch gears here and talk more about quality issues. And our next speaker is Jim Thompson. He's a Cooperative Extension Specialist and an Ag Engineer here in the Department of Biological and Ag Engineering at UC Davis. And he's going to talk about shipping strawberries, which is another very important aspect with regard to enhancing the quality and marketability of the product. So, Jim, I'll hand it over to you.
Thanks, Jim. I want to make a point very first off here. I have 10 minutes to talk, but I can summarize my whole talk in one sentence, and that is strawberries are very sensitive to temperature. And temperature management is the key to getting good quality of berries. Let me give you an example. We just did some testing a few weeks ago where we held some strawberries at 40 degrees Fahrenheit. That's about 5 degrees Celsius. We held them for just 6 hours. We kind of stopped the cooling midstream, held them at 40 degrees for 6 hours, and then finished cooling them, brought them down to 32 degrees. And that slight increase in temperature over a continuous cool all the way down to 32 degrees without a stop, we could see the difference in quality. So small amounts of time at temperatures above 32 degrees do result in poorer quality berries. So let's take a look and see how we can handle the berries. The first issue is to plan the load. The reefer thermostat must be set to 32 degrees. I really think it needs to be at 32. With the modern refrigeration equipment we have nowadays, has very good quality, very good ability to control temperatures, and we need to be setting thermostats at lower temperatures. I've heard of people setting thermostats in trucks at 31 degrees in commercial practice. Don't mix strawberries with other commodities that are held at warmer temperatures, like tomatoes, green beans, citrus, or tropical fruits. That's a compromised load from the beginning. If you set the thermostat down where strawberries need to be, it will be too cold for the warmer commodities, and they'll be damaged. If you set the thermostat at a compromise between the two requirements, then everything is compromised, and the quality of any of them won't be appropriate. So produce compatibility is a key issue. It's a part of any load that you plan. This is a chart that comes out of our highway trailer transportation book, and that's available through our center, our Postharvest Technology Center. And I won't go through the details, but it shows the key issues. The items in green are sensitive to ethylene. The items in red, both fruits and vegetables, are not sensitive and don't produce ethylene, and the items in blue produce ethylene. And so you have to control that issue. Strawberries, fortunately, are not sensitive to ethylene, so they can be mixed in that respect. But across the top of the chart is temperature requirements. And you can see there are a lot of products that are held near 32 degrees. Those are appropriate to mix with strawberries. The other products in the columns to the right are recommended to be held at higher temperatures, and those shouldn't be shipped with strawberries, just plain and simple. Precool the berries. The berries need to be cooled to 0 degrees Celsius or 32 degrees Fahrenheit before they're loaded. Strawberries almost always warm up in transport. This is particularly the case in the summer months when the outside temperatures are warm. We'll see significant warming. So the berries are going to be the coldest they are when they're loaded onto the truck. There is, of course, the exception when berries are being shipped to the northern states and to Canada during the winter months. But all of my recommendations for maintaining temperature will also protect berries when they're shipped during the cold months of the year. Of course, the key with the trailer is to make sure that it's not damaged. We've done an extensive amount of research at the university, and we found that refrigerated trailers work much better if they have both rear doors intact. The vehicle itself has to be cooled to 32 degrees before loading. The main goal of this is to make sure the refrigeration system works. Thermostat should be set to 32 degrees, and they need to be calibrated. When we're operating at set point temperatures of 32 degrees, you want to make sure the thermostat has been calibrated. The trucker particularly is interested in this because if it's producing temperatures that are too low, it has the potential of freezing. If it's too high, we may not see the damage, but it will damage the fruit. Now, key with strawberries when you load the product is to make sure they're not touching the sidewalls. So we want a centerline loading pattern, like you see in the top trailer there, the top view of the top trailer, where there's a separation. There's the blue separation bags giving a gap of at least a couple of inches between the walls and the fruit. And the reason for that is that the heat, most of the heat that the refrigeration system of the truck handles is heat that's conducted from the outside. This is up from the floor and through the walls and through the ceiling. And we need an air space so that the cold refrigerated air can scrub that heat that's coming in from the outside before it gets to the berries. This next slide shows a series of tests that we did a number of years ago and is an average of actually 7 loads of product leaving California in the summer months and going to Montreal. And it shows the average amount of warming in transit in a 3.5-day trip. And you can see in some locations the fruit were warming a little over 4 degrees Fahrenheit, 2.3 degrees Celsius. The minimum was a warming of 1.1 degree or 0.6 degrees Celsius. So again, this reinforces the idea the berries in the warm summer months are not going to be any colder than what they were when they were loaded into the truck. This shows the way to maintain a separation between the berries and the wall. You can use corrugated strips that have pressure-sensitive adhesive on them. Put those on the pallets of berries, and then berries go into the truck and side load against the walls. Another very common system is with these polyethylene airbags that are taped on the top of the pallet and then pressed against the walls or inflated in place. And they do a very good job of keeping the pallet load away from the walls of the vehicle. So when you receivers see strawberries arriving at your facility and you don't see these load spacers, there's a real potential for a problem. It should be a requirement for all berries. Freezing temperatures of berries. The actual temperatures that berries freeze are from 30.5 degrees Fahrenheit to 29.5. Depends on the soluble solids content. The more sugar, the sweeter they are. They freeze at lower temperatures. But remember, this is the temperature of the berries, not air temperature. If we have air temperatures that may go down to 30 degrees occasionally, that doesn't mean it's going to freeze the berries because they're protected from immediate temperature changes because of the packaging around them, and it just takes time for the berry temperatures to actually cool. They're usually in clamshells, and that has a little bit of protection also. And even then, even when the flesh temperature of a berry reaches these potential freezing temperatures, they may not actually freeze because it does take time for the ice crystals to actually form. So these are very safe temperatures for strawberries. Air ride suspension. This is another point now that we need to consider, and that is that vibration in transit can damage berries, and we would like to see air ride suspension on all vehicles that are carrying strawberries. The tractors have had air ride suspension for many years, but the trailers don't necessarily have air ride. Many of the new trailers do. Most of them do, as a matter of fact, but some old equipment doesn't have it. The picture at the bottom right shows the black metal airbags that you may see if you look underneath. You can tell the difference in those suspensions quite easily. They don't have springs, don't have leaf springs like other regular suspension does. The reason we want the air ride is that acceleration is amplified as it's transmitted from the floor of the trailer up through the pallet load. In fact, damaging levels of vibration rarely occur on the floor of a trailer, but the frequencies of vibration that will cause damage are actually amplified, and they can be amplified by a factor of 3 to 6, maybe 7 times as they're transmitted up through the corrugated boxes. That means that if you're going to see damage, it's going to be on the top 1 or 2 layers of boxes. And the worst vibration in the trailer is behind the rear wheels. And so when you open the doors of a truck and look at the top berries, if they're free of vibration damage, then you can guess that the rest of the load is. On the other hand, if those top trays are damaged, you may well not have significant levels of damage in the rest of the load, because the damage tends to be concentrated in the rear 1 or 2 pallet positions and the top 1 or 2 layers of boxes. At the distribution center, again, this is a key part of the cold chain. We need to make sure we remove pallet covers. If you have ordered modified atmosphere service, those covers need to be removed at the distribution facility. There are different types of covers that you may see. Some are sealed, like this one. They have the function of modifying the atmosphere, increasing the carbon dioxide levels, and they reduce damage associated with botrytis growth, with decay growth. There are other types of covers that aren't sealed. They don't produce high levels of carbon dioxide and don't serve that function. At the distribution center, we continue to want to hold the berries at 32 degrees. Now, if I had time to give everybody on the call here a test, it would be to ask you whether this load of strawberries is being held at 32 degrees. I'll wait for a second. Can you see the clues there? The biggest clue is that the gentleman taking the pallet cover off doesn't have gloves on. It doesn't have a hood on. When you go at the distribution facility, it should be cold enough around strawberries that you need to look like you've just come from northern Canada. It needs to be cold in those areas, and people that work in those areas have gloves, insulated coveralls, and fur-lined hoods around them. That's what strawberries need. That's it. I think I've told you the 2 key issues: keep the berries cold and protect them from vibration damage.
Thank you very much, Jim. That was a great presentation and a great overview. Do you have any questions for Jim? I've got one to start with, just to get the Q&A going here a little bit. With regard to those pallet covers, Jim, does that warm the berries up in transit, or is there should we expect the berries to be warmer, and by how much potentially?
Yeah, the tests that were done on this showed that there's about a 2 degree Fahrenheit, 1 degree Celsius rise in temperature in berries in pallets compared with berries that are not having pallet covers. And so there is a little bit of increase in temperature. They still have benefits for quality in spite of the temperature increase, but it does mean, though, that if you're going to use pallet covers, you need to make sure that the temperature management is done very well. Berries need to be carefully pre-cooled and temperatures measured, guaranteeing they're down at 32 degrees before covering, and they're loaded correctly in the trailer.
Jim, excellent presentation. Thank you. I have a couple of questions. The first one is, when you did your test, when you brought the temperature before pre-cooling it back down to 40 degrees for 6 hours and you saw some deterioration starting, what would you say after pre-cooling upon arrival into DC that, let's say at 40 degrees, just as an example, 6 hours, then 12 hours, then 24 hours, what can be expected?
So, Lumi, your question is, if you're holding the berries at the DC at 40 degrees for 6 to 24 hours, how much damage would you might see?
Yes, and how would it be progressing?
I can't give you a specific answer on how much damage there would be. There will be some, and you will see it in terms of increased decay growth. You'll see it in terms of bruising becoming more evident. The berries will look more tired. They'll lose their bright sheen. Those are the general sorts of damage that we see with strawberries as they progress.
Thank you. And my other question is this compatibility chart. Is there a way to get a copy of that?
Absolutely. You can order our publication on on highway transport.
Thanks, Jim, for the presentation. Question on the bags. Has there been a cost-benefit analysis really on product going east? And at what point is there truly a benefit to having those bags on the fruit?
Cost benefit. I can't, Greg. I can't answer your question about cost benefit. I can answer your question in terms there is a benefit in terms of quality of the berries using the modified atmosphere bags, the sealed bags. Those have been tested quite extensively. In terms of the cost benefit, that would probably depend mostly on the value of the berries, but. At any rate, there is a benefit associated with using the modified atmosphere bags.
I would assume that obviously the further you go east, the more valuable it would be.
I see your question. Yeah, if it's short distances, perhaps there's less potential for getting an economic benefit from it. And I don't know what that distance is, but your thinking is correct. You know, the length of the trip would influence the value of the modified atmosphere bags.
Jim, this is Beth Mitchum. If I might add, also during periods where the weather is more foggy or rainy and there's greater potential for mold growth, then you tend to see more of a benefit from the modified atmosphere bags during that period of time.
So, Beth, you're talking about fog and rain in the production area.
Right.
Yes.
Great point. Thank you.
Good morning. A question I have is more this. When we're tracking claims, because I'm sure everybody gets claims from either side, one of the most difficult issues for me personally is to find a temperature recorder of the refrigerated trailer. What can be, is there any more thoughts into something GPS-based where you really take the temperature out of the hands of the trucker?
Okay. There is the potential for using GPS-type systems. I'm not sure that they're particularly available because of cost kind of issues. And so what you're saying is if somebody other than the trucker was monitoring the temperature in transit, then people would have more confidence that the berries were being handled correctly. The next generation of RFID tags have temperature sensors built in them. And if you even had one of those tags on a pallet, per pallet, you would see very clearly what the temperature was of that product. And that sort of technology is available nowadays.
We've got time for one more question.
When you said that the temperature is raised 1 to 2 degrees when you are in transit with the Tektral or atmospheric bags on it, what was that temperature run at? Was that at 32 degrees? And if so, how much more would it go up as the temperature on the truck, say, was at 34 or 35 degrees? Does it multiply? And then I have a second question of, you were talking about with the airbags on the walls, what happens if a temp recorder is stuck to the wall where the heat is being transferred from the outside, as well as you said that the temperature that is coming in is being transferred from either the floor or the wall?
Okay, good questions. As I remember correctly, that test that was done showing the temperature warming, the air temperature of that load was right at about 32 degrees. And I think you're probably right. If the air temperature were set at 34, we might see a greater rise. But I haven't, and actually I think that study did look at that a little bit. But I don't have it in front of me, so I can't tell you exactly. But the tendency would be to happen, which you just said, that the warmer the carrying temperature is of the truck, the greater potential for increased temperature rise in a bag. All the reason for setting the thermostat at 32 degrees if you use modified atmosphere bags. Your second question about putting a temperature recorder against the wall is exactly right. It's one of the warmer areas in the truck. And so if it is stuck against the wall, it's going to be slightly warmer. It's going to be measuring a warmer condition than other areas of the load. It's a key issue with temperature recorders. You need to know where they're placed to be able to interpret what that data means.
So would the correct place to be for the placement be on the front of the pallet, or where would the suggested placement of that recorder be to get the truest reading?
Well, the temperature recorders are mainly useful in determining the temperature of the air coming from the refrigeration system. They're not very good at measuring pulp temperatures. Otherwise, you'd have to have actual probes that go into the fruit.
Correct.
So they will measure air temperatures. So in some location that's reflecting the temperature of the air coming from the refrigeration system, this allows you to see whether the refrigeration system is working correctly. So that would be the top of the last couple of pallet positions. Would be good places for that.
Okay, thank you very much.
Thank you very much, Jim.